Hey guys, I'm an intern from SIMMI Foundation and we work towards the benefit of mankind. Current aim is education for all. So what are we waiting for? Let's get started.
Okay, so let's move on to another question. In this question, it is asked to find the molarity of the solution. But this is a slightly different problem as compared to the ones which we had solved earlier. In this problem, we are not given the number of moles exactly, but we are given the amount of the substance, that is NaCl in this case, in grams. Over here it is mentioned in grams, and that is 58.44 grams. And as we all know the formula for molarity, we should always start with writing the formula for molarity. Molarity is equal to number of moles divided by volume in liter. So here, instead of number of moles, we are given the amount in grams, and also they have provided us with molar mass of NaCl. The volume given to us here is in liters, so no issue of conversion. So let us write first what all is given to us. Given volume, which is 2 liters, molar mass. The molar mass for NaCl is 58.44 grams per mole. The unit is very important. And we are also given the mass of NaCl. So the mass of NaCl is also written over here as 58.44, which is the same as its molar mass. So now let's move on to the calculation part. We must know one thing, that number of moles, this is a very important formula, is equal to mass of that substance divided by its molar mass. This is a very important formula which should be remembered. So now let's start substituting the values in this given formula. First of all, number of moles is equal to the mass. Over here it is given as 58.44 grams, so we write it as 58.44 grams, and the molar mass comes in the denominator, which is also 58.44 grams per mole. Now if we divide it, the answer we get it as 1.00 moles. So it is 1.0 mole. Now that we have found the number of moles, which is 1, we can substitute the value of number of moles over here in this formula for molarity and get the answer for the molarity. So let's get the answer by substituting the values. Molarity, I'll write it here, short form as capital M, is equal to number of moles, which we have just found out, 1.00, and the denominator having volume, which is 2 liters. And as we all know that 1 divided by 2 is 0.5. So the molarity of NaCl solution is 0.5 molar. Instead of molar, it can also be written as 0.5 moles per liter. This unit can also be used. Since the unit for number of moles is mole and the unit for volume is liters, so we can also use this along with molar as its unit. Now let's find out some easy way by which we can easily get the molarity or volume of that particular solution by using this formula, or indirectly by adding this formula into this formula, or establishing a relationship between these two formulae. So as we have said, molarity is equal to moles, number of moles, divided by the volume. If we take this volume on the left hand side, then it gets multiplied to the molarity and we will get the answer, or the final result is M into V is equal to moles. Let us consider this as equation 1. And just now we have seen that number of moles is equal to the mass, that is given mass, upon molar mass. Let us write this as equation 2. Now we substitute equation 2 in equation 1. And the final answer we get as molarity into volume is equal to mass upon the molar mass. So this is the overall relationship which we have got using these two formulas. First of all, these relationships needs to be kept in mind, as this formula is very useful and makes the calculations much more easier.